Hey, yeah, hello everyone. I hope that you guys are enjoying this whole webdev live India sessions. And myself, Ashok Vishwakarma. I I work as a principal architect at Naukri, and I happens to be a Google developer expert as well for web category specifically. In this specific talk, I would like to address some of the new feature which React 16.8 got in terms of hooks and context APIs. And the agenda, actually, the agenda for today is pretty straightforward. I'll just go and introduce a little bit about React, that what React is, and how you can get started with it. Then I'll actually talk about some specific challenges which we face while actually using React in bigger and larger projects, and then I'll move to introducing you to hooks, how they are implemented and how you can get it started with, and then we'll have some introduction around context, and after that we'll put everything together and see that where and how you can take this into your next project. So first thing first, what's exactly what is React? So it's a JavaScript library to build user interfaces, which is pretty much mentioned on their react.org website as well. So in general, what React is, for my understanding, is it gives you some specific features to actually compose your specific HTML layout into certain parts, and those specific parts they call as a component. These are the few specific terminology which we use inside React, which is component. They are the core building blocks of any specific React app. Then they have props. Props are we call those specific properties which we pass actually from one component to another, and every specific React component have a state which is internal state, and they manage that state to re-render and display some specific information and do the change and change detection and etc. Apart from that, they also have lifecycle methods. These methods are some specific callbacks which we get on certain and various stages of React component lifecycle. So actually, let's talk about a little bit about the component, that what type of components we have in React. So one is a function component. If you see this example, this is a very simple counter component, and it's a pure function component. It can only receive information through props. So I have count and set count, which is coming from the parent component, and then using that I'm just displaying the count, and there's a one callback to set count to either increment it or to decrement it. The properties of a function component is they also called a stateless component, and as I mentioned earlier, that the parent can only pass the data using props. They do not have any specific state, and they don't own it at all, and they also don't support any lifecycle methods. So you can call they are pure functions which just return JSX and receive some information through props which we can display inside that specific JSX. Similarly, we have class component, but these components are pretty different than the function components. And here is an example of the same counter into a class component. You see that now instead of creating a function counter, I'm creating a class counter, and that particular class is extended using React component. You can also use uh, pure component as well. That's also class component. And then you can see that I'm also defining a state which is count, and I'm setting the initial value of count to 1. And then I've declared two specific method. One is a plus and one is minus. And these two methods, what I'm doing is I'm just incrementing and decrementing the state value of that count. And in the render, I'm using the same JSX which I was using earlier. And rather than taking the values and information from the props, I'm using those values from the props from the state directly. And these specific two methods which I binded and I'm using on especially as a handlers. So so in especially in class components, what you see is they extend React.component or React.pure component, similar to function component. Actually, class component can also receive information from their parent, and they have their own state, and they also support lifecycle methods, which will look into that. So it's good that we use React and we build lots of projects around that. But there are certain challenges which I like to address, which we face in especially in React when actually working on some specific big projects and large scale applications. So first challenge which I face is very common is reusing logic. So components are the basic building blocks of React apps, and they have two ways to share stateful logic between components, and those specific methods are high order components and render props, which are great for few specific cases, but they also have some specific downside. If you need to use any of these specific methodology in your specific component, you need to restructure in a component in a way that you can support this particular features over there. uh, for example, if you're using a function component, you have to create a class component, and then you also have to restructure your specific component into parent and child system, so that parent can send the information, and that parent is also called the high order components over there. Render props is something where you can send the information through your props and stuff like that. So this specific restructuring actually leads to one specific problem, which is called wrapper hell. uh, the wrapper hell is this whole specific nesting of your React application, which you end up having because of those specific changes which you have made to actually avail either render props or high order components. If you look at this particular screenshot, uh, you can understand that it would be really difficult to follow the data flow throughout this component tree, and it would be really nice if there would be some specific way to share this spaceful logic without needing to restructuring this component into this specific way. The next problem which I would like to talk about is actually giant components. So when you build a large application in React, you end up having very big and giant components. And the problem with these components are because the life uh, actually the life cycle methods are designed in a way that you have to spread your logic around those specific methods, and they become very cumbersome time to time. So let's take a look an example and see what I'm trying to say here. So first thing is, like, if you have one specific class component, which you can see here, and you have one specific lifecycle method which is called component dead mount. What component dead mount do is it just fires up when your component is actually mounted into your viewport, and and in this particular method, what I'm actually doing is I'm doing three things. One is I'm subscribing to a store to get some information. I'm making a network call to get some additional information about that particular item, and I'm also starting a timer at the same time. The next component method is which I'm using is which is called component will unmount. This get fired when your component is leaving your view. I mean, it's removing completely from your current page. And inside that, I'm also doing the exactly same things, but opposite to what I was doing in component dead mount. Uh, I'm unsubscribing. Uh, Actually, I'm unsubscribing the subscription which I've created to the store. I'm also canceling any specific pending request which I have, and I'm also stopping the timer which I've started. Similarly, if we also consider component did update, then the whole thing going to be a little more messy, because in this particular method you have to compare from previous props to next props and then do your specific logic around that. So if you check this particular example, what exactly happens is, because logic is spread through these specific lifecycle methods, and it's very hard to follow if this component is pretty designed. Like this specific scenario, I'm just doing these three specific things, but in more real life examples, this case is going to be a little more complex. And most of the time what happens is, when you look at those specific components, you don't understand what exactly is going on, because you have to scan through all of the component lifecycle methods to understand what exactly that component is doing. And that is going to be a little bit hard to understand at the first. And the second thing, it's also going to lose some of those specific edge cases where you end up making mistakes, and ends to leak the which ends to have some memory leaks in your application. For example, if I subscribe to a store, or maybe started a timer, but if I don't follow the code properly, I might actually forget to do any unsubscription, or stopping the timer which I've started. And in that case, my timer will be keep running, and I'll actually end up having some specific memory leaks over there. The other problem, which I also see in in React specific, is because classes are the only way, as of now, which you can achieve life cycle methods, or maybe stateful logic. And classes have certain specific challenges of their own. Like these classes in JavaScript are little tricky, because you have to understand how this works, how binding works if you are making an object out of it, and stuff like that. And classes also add fair amount of boilerplate into your code, like that constructor syntax, and then that this and 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 specifically those binding in React, because we have to bind every method so that it can work inside a callback, or as a callback specifically. Apart from that, I've also seen that developers who use React have some fear about functional component, because they don't know when they needed to be using state, or maybe lifecycle hooks. So it's very difficult to decide whether I should go for a component, a function component, or a class component, because there always going to be a specific fear in your mind that later on I might needed these state and lifecycle hooks inside that component, and I have to convert this particular function component into a class component. So should I do it right now, or I should be doing at the time of when I'll be needing that? So specifically, that particular confusing with classes is actually there. And classes is also a little hard for machines as well. Like if you see minified version of your specific class, you see that methods and properties are not minified, because they can be used runtime and other specification to that. And unused methods and unused properties also don't get stripped out, because there's always going to be a chance to get them used actually from the object. And implementing a reliable hot reloading in case of React when using classes is also a little challenging, and that they mention in various places in the documentation as well. And with the classes, they also have a little bit challenge on compile time optimization of your whole React application. So these are the three specific problems which we have talked so far, and I think these problems are because there is no simpler way which we can use to manage state inside a class, inside a function component, and the only way which we have is using class component. So to solve that problem, in React 16.8, they have introduced hooks. So what hooks are, typically that let you use state and other React features without writing a class. And they also provide some sort of and they also provide a way to share logic among these specific components, specifically stateful logic, so that you don't have to restructure your code and you end up having wrapper hell specifically over there. So let's take the same example which we have created, which we have seen on the function component example. In this particular example, what you see is like I'm just using this count and the set count method, but I don't know where I should be getting from. So in React Hook, what we have here is we have a use state method exported inside the React package, and that use state method returns you uh, an array, and that array contains a specific variable which contains the value which you initially set to that, and there is one specific method by which you can set the new value to that particular variable, and this is a stateful value. So if you see this particular syntax, now the count and set count is going to be reside in this particular component only, and they're going to affect only this particular component. Similarly, how the set state works in class component. And if you want to declare multiple variables and multiple state to your specific component, what you can do is you can just call this use state method multiple times. Few things to note here. One is it returns a stateful value and a function to update that value. It's render on each update call. I mean, each time you call set age, set fruit, or set to dos, it's actually going to be re-render the whole it's actually going to re-render the whole component itself. And unlike the set state method in classes, in this use state, you don't get your state values merged, which means like if you try to do something which is like an array or an object, and you assume that if I already have some values on that particular object, and I'm just adding the new one, you won't get the older one. You won't get the older values because it's going to replace the value which you're going to pretty much call on next update. Another hook in React is called use effect. So what use effect does is it lets you use those specific lifecycle methods inside your React function component. So a lifecycle method, it can be either component in mount or component will unmount, and there are certain other lifecycle methods as well. So this use effect state, it actually takes a specific callback, and that callback get called every time your component re-renders. And if you see this particular example, what I'm doing here is every time I'm updating my count, I also wanted to update my document title so that my count values gets reflected on my document title as well. And in this example, every time I click that button, it's gonna do two things. It's gonna actually update the state which I'm using set count to, and then it's also going and then it's come to the effect section, and in that effect section, it's going to use that document the title syntax, and by which it's gonna update the document title with the updated count. Similarly, there are some specific cases where you also want to clean up after your effect. So every effect can also return an optional function, and that function get calls when your component is unmounted, like if when actually going to remove from your current phase. And there is a second optional parameter to the use effect method as well, which is kind of your component data update thing, in which you have previous props and next props, and based on that you do some specific diffing, and based on that diffing you render or not render your specific component. So in this particular scenario, React gonna do that particular diff at their own, and you just have to pass that what sort of properties you care about and what sort of property changes you want this component to re-render. So in here, in this example, what I'm doing is I'm just making a call to API to get the initial count and then setting that count to the count value. and also returning a method which gonna cancel any specific pending request which I have. And I'm also making sure that my effect only runs when my props.change is changed. So in this, so as in effects, it's accept a function, it's fire on mount and update by default, a cleanup called on unmount, and conditioning firing based on that particular second argument which we have. The another hook which we have is called use context. So context is also get introduced recently in the React, and I'll have a complete introduction of context later. But in this example, what we are trying to do is we are trying to use a theme context inside a function component. And if you see that I'm just using use context method and passing the context inside that, I'm getting a theme variable, and that I'm directly using as in a object from a style property. So in the code, how this particular context going to look like is going to have some certain theme and some specific object like style sheet objects, and that I'm using directly to style my specific component. And the way use context works is accepted context object, which you can create by using create context, and it return the current context value. So context are pretty much like a pub/sub model inside the React, which we'll talk in the context section. And it's also attached the nearest context providers. So if you have a hierarchy of component and you have multiple provider in your application, the first the nearest parent which gonna have that particular context provider, that is going to attach to, and it's re-renders every time that context value get changed. Another way of using state inside a component is through reducer. Reducer is a new specific hook, and it's pretty similar to actually use state. But the only difference is instead of passing that set count or maybe set method of that particular variable, what you get a dispatch method. And in dispatch, you can dispatch whatever action you want to dispatch to either update and decrement the state which you want. It's pretty similar the way we use reducer in Redux, which we have create some action, and then that action gonna have some specific type and some specific payload, and based on that payload and then specific type, we have some switch cases and then that reducer function which we pass inside the connect component and stuff like that. So it's going to be pretty similar. It's actually pretty similar to that. The use reducer actually accepts it's actually an alternative to use states, because this use reducer is also going to affect this specific component only. If you're trying to if you're updating the value or dispatching an action from this specific component, it's not going to other specific component where you may have used the same reducer and passed the same state and same action, because this works as an alternative to state. And it's accept a render function, a reducer function, and an initial state, similar to other reducer function which we used to create in Redux. And it's return current state and dispatch. So whatever the current value of that particular state gonna be, that is going to be returned, and then it's also going to return a dispatch whatever action you want. And every time you dispatch a method, and if you change the state value inside your reducer method, then it's going to re-render. So the other hook which we have is called use callback, and it helps you to create memoized callbacks. What memoized callbacks are is like whatever the value on that particular variable you get returned, it's gonna memorize that and put into a memory, and each time you're gonna use that callback with the same argument instead of doing that computation and again, it's gonna return you value from the cache directly. So that's what a memoized callback is, and it's pretty simple to use. It actually accepts a function, returns a memoized callback, which you can call anywhere in your application, and it's recomputed on the dependency changes. So in this example, if the value of A or B actually gets changed, then your memorize callback's return value will be changed. Otherwise, it's gonna be the same. And it's also good for child callbacks. Like if you have some specific child where you want to pass a callback, and in that callback you want to have some specific values to be sent to the children, and you only want that value to be and you only want your children to get the updated value you when you manually update it, then this is the way you can achieve that. The other one is also pretty similar to use callback, but this, instead of returning a callback, it actually returns a value. So use memo is the next hook, which is here, and this as you see in this example, what is actually doing is taking a callback, and that callback have one specific method, like it's computing some specific information, and then that value is going to be cached. So every time you call this specific method, this specific value going to be persisted in the memory, and it's gonna be returning directly from the memory instead of doing this whole compute thing again and again. And it's also very similar to use callback. It's actually accept a function, but instead of returning a memoized callback, it's return a memoized value, and it runs during the rendering. So you have to be a little careful while using this specific use memo, because when your application component is rendering, it's it can run your memoized value. So your memoized value might be different based on your props, or maybe other properties which you are using to pass into that particular function. And it's also get recomputed it if any of the dependency or any specific callback get called. The other thing which I want to talk about is use ref. And how use ref works is it's similar to the ref which we are pretty uh, used to use in React space. Like this particular input element, if you want to create a ref out of it, it's going to get you that particular ref into the current specific property, and you can do certain things on that. So it's something like if you want to access a DOM node using inside a React component, and then you want to use that DOM node to do certain things, certain DOM operations, and then you can do that by using this. And the way it works is it's written on a mutable ref object, and on dot current represent the pass value. So if you're passing null, then it's going to be null, and then it's going to have that null get replaced with the actual element. So your input element will be available on input element dot current, and then you can do certain things on that particular thing. Like maybe in this example, what I'm doing is I'm just focusing out that particular input element, and it persists for lifetime. So this whole component lifetime, this input element gonna be there, and and it doesn't notify any specific content changes. So it's just a reference object, nothing more than that. There are some other hooks like use imperative handle. So it's similar to it's helpful when you're using ref, and instead of just returning the object with the current element, you can customize the instance of it and expose it to parent and stuff like that. And then other hook is use layout effect, which is identical to use effect, but it is fired sequentially after the DOM mutation. So if you want to use any mutations like mutation observer, or maybe window scroll event and stuff like that, you can use this use layout effect, and it's going to be a little bit and they're going to be a little bit performance benefit to that. And the other hook is use debug value, which is purely for React Dev Tools. So if you're using React Dev Tools, you can pass any custom hook or any custom value or display a label to a hook by using use debug value. The best thing about hook is they are composable. So you can create your own hook if you want. So if you see this particular example, I'm creating a hook called use win width, which is using window width and inside the component by listening to window.resize event. And this is an implementation of getting the width value of any specific window while resizing and after resizing, or before resizing, maybe on the load and stuff like that. And because and if you see a specific pattern there, because I'm also using use bin width instead of any specific name. So React has also have released one specific linting system over there. So if you want to use and create custom hooks, make sure you name you name you name them in this way, so that the linting works. And the benefits and the properties of custom hooks are, they can be composed using multiple hooks. If you see this example, I'm using use state and use effect both to actually compose my use win width, and they can be shared among components. So this can be a utility method which I can expose through export, and then they can be used anywhere we want. And they act individually, so they don't relate to or link these the components they are going to use with. I mean, they're going to be independent towards the component which they're using. So any specific state change or any specific effect you do in your custom specific hooks, they're gonna only rely to that particular component only. And so far what I've discussed is, because how you can actually create state and life cycle in a function component, how you can actually manage state and life cycle methods inside a component, inside a function component. And the one specific rule for hooks are, they cannot be called conditionally. So you need to make sure that they are independent, they are independently called, and their value you can use conditionally if you want. And they are composable, so you can create custom hooks and you can compose them in a various way. And they are very easy to extract outside the component, so you can split out your logic tree into various custom hooks and stuff like that. Next is context. So what context is, it's provide a way to pass a data through component tree without having to pass props down manually at every specific label. So currently how React is pretty much taking data from inside the component tree is only using through props. So what context does is, it's actually let you create a context by using create context, and it gets you two specific things. One is called provider and the other one is called consumer. So consumer and provider are pretty similar in a way, the similar we use these pub/sub models. So this provider is going to be your producers, and this consumer is going to be your consumer specifically. So anywhere you want to consume this value sent and updated by provider, you need to use this consumer component. And the create context method actually returns a context object which contains provider and consumer, and it also can have a display name, which is very helpful when you're using React Dev tools actually. And it can be used in either components, like either a class component or a function component. In both component types, you can use context. So as I mentioned, you're gonna get context.provider, which gonna lets you to consume and subscribe those specific changes, and similarly a consumer which gonna re-render and any context changes which you can do onto those specific methods. So let's create a simple shared store using context and use reducer hook. The example goes can also be found on this particular URL which I mentioned there. So in this thing, what I'm going to do is I'm going to create a reducer, which is, this is a very simple reducer method. I'm just having one plus and minus method over there, and I'm just incrementing the state of the count property of the state, either incrementing that or decrementing that. And then I'm creating a context out of that state and reducer which I've defined. And then this specific component which I'm exporting over here is called store provider, and inside that store provider component I'm using use reducer. So that reducer function which I've created earlier I'm using as a actually using inside that state provider component. and and whatever and whoever is going to use this store provider component, I'm wrapping them into that context provider, which going to help me re-render this whole thing with when everything gets changed on the user. And that context dot provider gonna require a value, so I'm passing the state and dispatch method so that anybody who is using the use context method inside that particular component, they can subscribe to and dispatch any method from that reducer. And if you see, I'm exporting that use context as a custom hook over here called use store. So instead of using use context, I'll be using use store over there. And here is my simple example of app where I'm using my store provider, which I've just created, and wrapping the app component inside that. And then in this example, if you see that counter component is actually using that use store which I'm created in the store, and that is dispatching the plus and minus stuff over there. So if you want to look at the code, the URL is mentioned below, and this works pretty much that way. And then this is a count, and this is where I'm using that counter component at all. Like I'm just importing that counter component and just using it into this app component. So what we have seen so far is if React have some specific challenges if we are using classes, and with the hooks we can write down our React component in a better and cleaner way. I mean, when you have that particular feasibility to strip down your component logic into multiple files or into multiple utilities and methods, then definitely you can structure and restructure your code in a way that it's going to be more readable, it's going to be actually more cleaner. And there are and in the React conf, they also mentioned that there is no plan to remove classes from the React. So I would suggest that don't rest and start migrating your classes as of now. But yeah, I mean, keep an eye, because this, as per their documentation and as per their emotion, it's going to be future for the React, and they're going to keep developing React in that particular direction. And these hooks are 100% backward compatible, so you don't have any breaking changes. It's completely opt-out basis. If you want to use it, you can use it. Context API makes reuse difficult, so apply it sparingly if you want. Like, just be a little cautious when you're using context APIs. Don't try to put everything into the context and try to access everything from the context. So that's all. Thank you to be here, and thank you to listen to it. Have a good day.